Okay, this video is to help you in Calculus 1 do your second derivative card for the year. And we've done a derivative card already, but we're learning the chain rule. And so if you have a card at home to do this, if not, you can wait till you come into class. But to show you what is going to be on your derivative card. So I have these big index cards in class. And so far, we've have these following functions. So this is the front of the card where you're going to have your function on the left. And on your right, you're going to have the derivative. And I've kind of chunked them up. So we did a power function, then we did exponential functions, then we have trig functions, and then we're going to add log functions, but we're not in this video. I will do those later. And so you can stop this video at any time that you need to copy anything down, but you should have go from 1 to 11 on the front of your card. We'll do additional cards as the year progresses, but this will help you study. So I'm going to go through and just do the derivative of each one of these. And the first one is a power function. And when we add the chain rule, we have to, you can see these a number of different ways online, but I'm just going to use it as a y prime equals, and then we're going to say n times u to the n minus 1. And then we're going to say times u prime. So that is going to be now the new power rule because you have to make sure that you take care of your composite functions. The second one is y prime is now going to be e to the u times u prime. 3 is y is a to the u, natural log the base, times u prime. The derivative of sine is now going to change to, this is y prime. Y prime equals the cosine of u times u prime. Cosine is y prime is going to be the negative sine of u times u prime. Tangent is going to be y prime equals secant squared of u times u prime, or you could use it as 1 over cosine squared u times u prime. And sometimes you'll see it u prime all over cosine squared u. So I'm just writing like this so that you can keep it in the same method. This is a little crooked, so I'm going to fix that a little bit. So sometimes you will see it online as u prime over cosine squared u because this literally could be on the top of that fraction. For cotangent u, it's going to be y prime equals negative cosecant squared u times u prime. And you could see that, or you could see it as negative 1 over sine squared u times u prime. So you could see that as well. So I'm kind of going on the next line here. Cotan is the derivative of, so I got cosine, tan, cotan. Okay, secant of u, that's the one is next, is y prime is secant u. Okay, and then it's tan u times u, tan u times u prime. Okay, and cosecant u is going to be y prime is negative cosecant u. Oops, I'm trying to go ahead to it. Cotan u times u prime. And we will be adding logs later on, but not in this video. So basically, all of these are the same derivatives we've learned, but you'll notice that I'm multiplying everything by u prime, and I chained it instead of x's to be u for the chain rule. Now on the back of the card, we have the product rule. That hasn't changed. So you have y equals f times g. Y prime is f prime g plus fg prime. We have the quotient rule. If I had a function y equals f over g, y prime is f prime g minus fg prime over g squared. And leave a spot for log properties because we'll be using that later on. And change the base formula. So there's a spot there in the back of your card. You can add other things to the back of your card. We had trig identities there where we had the main trig identity to be sine squared theta plus cosine squared theta equals 1. Then when I divide by cosine squared theta, I have tangent squared theta plus 1 equals secant squared. Or if I divide by sine squared theta, I have 1 plus cotangent squared theta equals cosecant squared theta. So those are the two other identities we get from our main trig identity here. So this is the one I kind of memorize the most, and then I know the cotans are together, or the cofunctions are together, and the tangent secant are together. And then the last one is your trig square, which helps you with the derivatives. That the derivative of sine theta is cosine, the derivative of cosine theta is negative sine, the derivative of negative sine is negative cosine, and the derivative of negative cosine is sine, and then it keeps going around and around. And we'll be using that later actually with antiderivatives too. So I just wanted to do this quick little video that you can make your own card at home, or you can do this on a sheet of paper so you'll have everything in one spot.